Hi everyone. In this video I will show you my code to simulate the sensor wireless network, okay, in Matlab, and how to detect the defected nodes. Okay, so let's start right away. Here is a code, and it's a GUI code, so let's run it. And here you go, this is the software. Now, this is the area where you're gonna see results, and you're gonna see the built network. And here is the parameters for building the network. Now, these three parameters for build, that's all what you need to build your network. Just tell the program the number of nodes and the length and width of the area, okay, that contains all this number of nodes, of course in meters. So what I have entered is 100 nodes, and this is the initial value. Of course you can change this to whatever you want, so it's up to you. So it's 100 node, and it is 500 meters, and 500 meters also width. So you have a square of 500 times 500. Now, this all what you need to build your network. The program automatically generates the best positions for all the nodes and the best connectivity by optimizing the position. Okay, and connecting the node to all its neighbors nodes which are in its radio range. So each node has a radio range, so it's connected to all the nodes in its range, but it's not connected to another node outside of this range. Okay, then to go from one to another, you have to go through a lot of nodes. Oh, and we're gonna see this. Now, what is here, these two values, are the values used to detect the attacked node or the nodes that are not functioning well. This happens a lot in the wireless sensor network, especially in a underwater wireless sensor network, because these are subjected to a lot of errors, that sort of stuff. Okay, so these two values are used to detect the detected nodes, and what I am using here is the SVM classifier, okay, to be able to do some sort of machine learning to detect the defected node. So you have to train the model and then try, and this all will happen when you hit generate. Okay, before we do this, what are the two values? Here is the expected sensor reading. Let's say that you are sensing temperature. So what I am having here will be 25, which is like the temperature that you expect the sensors to give you data very close to this value. Okay, so let's say this temperature. Of course, this is works also for any detected reading. Okay, if you're sensing attitude, pressure, whatever. Okay, now the size of the data bucket, that is the data which you the node is sending. Okay, there is a central receiver for all the nodes, so this is how the wireless sensor network works, and it receives buckets of data from the nodes, and the expected size of this node is 5. Now these two features are enough to detect the bad nodes. Okay, they cover most of the known defects that happens to node. Okay, let's start right away and hit generate network. Okay, this what happens. So here you see the good formation for the nodes, and here you see the connectivity of all the nodes together. So you can see that this node is not connected to a very far away node, so you have to move around with it. Okay, also you see that there is a training set that is used to train the SVM model, and here is the sensor read, here is the bucket size, and here is the status. Now I am training the model, the SVM model, that whenever data is away from the expected data, okay, it is status is -1, which means it is a bad node, and 1 means it's a good node. And of course the same goes for bucket size. What you do is you do an SVM model and you train it to the best. Okay, and here you also see this is one example for a good node. Okay? So you see that if the data is very close to the nominal values, it is good point. Okay, this simulation is really close to the normal and the real simulation, because it depends on normal distribution of values, so it is really quite close to reality. Okay, now we have trained the model, and here is the training error, okay, for the model. Now let's detect attacks. When you do this, what you do is as follows: the program randomly selects some nodes and set these nodes as bad nodes, okay? And then what you do is that you apply the SVM model which you have already trained here. You reapply it again, you do it again, but this time you're not training, you are testing, okay? And you know the program knows which nodes are attacked and which nodes are not. So if the node is red, this means that it is attacked. If it is circled by a red circle, it means that it has been detected as an attacked node. So whenever it is a red dot and it is circled by a red circle, which means it has been correctly detected by the SVM model. Okay, so we see that all of them are correctly detected, so we have a testing error of 0. Now let's keep trying this. Because it randomly generates different shapes and different situations, and we see that the worst case is like 2 nodes out of the detection method. So let's generate. Okay, here is another network. Okay, and it didn't detect attack. Okay, it is still 0 nodes. Let's try again. That's good. It means that it is a good model. It works well. Okay, so again. Okay, and here you go. Now one of the models give you errors. That's of course normal, and this is expected. You don't have 100% working detection method. There is always an error. So here is the errors. There is nodes which are, we know that they are bad nodes, and they are not detected by the SVM model as bad nodes. So the error is just 2 nodes. Okay, but when you keep doing the simulation and see the work of the model, you see that most of the time it is giving you 0 errors, which means all the nodes are detected correctly as bad nodes. So it can be used very well to simulate real data and see the effect of machine learning and SVM to detect this. Okay, I hope you like this video. You will find the video in the description, and I hope you subscribe to my channel. Thank you.